Hi everyone, welcome to another tutorial of linear algebra. Today I'll be covering on how to apply Gaussian method to solve system of linear equations of higher dimensions, which in other words, higher unknowns. So these are some examples. So the first two examples will be based on two unknowns. And the last four examples will be on higher dimensions like x, y, and z, except for d. But in this case, we may not know if the system has a unique solution. Like in my previous video, we did base on systems which have unique solutions. So now let's take a look at how we do the first one. So this is the first equation. So my first step, I swap. So what do? We want to eliminate the x variable in the second row, so that we can reduce it to an echelon form. So we swap row 1 with row 2, and hence we get this transform equation. So after this, we are able to eliminate the x variable in the second row. So we add minus 2 times of row 1 to row 2. So the left hand side will be as this, minus 2 times x minus 4y plus 2x plus 2y will give me 10y. And on the right hand side, 0 plus 5 will give me 5. Hence, this will be my transform equation. X minus 4y equals to 0 and 10y equals to 5. Hence, I get into this echelon form, and I can find the value that y equals to half, and when I sub into my first row, I get x equals to 2. The same goes for the second one. So now for this one, I eliminate the x variable. So what do? I add row 1 to row 2, hence giving me this equation, x plus y equals to 1. From here, I transform to here. So this is how left hand side works and the right hand side works. And I can find the value of each variable. So row 2 shows that y equals to 3 over 2, and subbing into row 1 will give me x equals to half. So now let's start with higher dimension. So we have this equation. So what do I do first? So you want to eliminate, first things first, you want to eliminate the x variable first in the second row. So we add minus 1 times of row 1 to row 2. So the left hand side works in this way. So we have minus times x minus 3y plus z plus x plus y plus 2z will give me 4y plus z. And for the right hand side is minus 1 plus 14 equals to 13. Hence we get this equation. From here, we transform to here. So now, in this example, there is a variable which is not a leading variable, which is z. You notice for the first row, x is the leading variable, but for the second row, y is the leading variable. So hence, z is not the leading variable. And since the system has at least one variable which is not a leading variable, in this case, the system has z which is not a leading variable. Therefore, the system has many solutions. So let's take a look at another example, which is D. Okay, for D, we are given this equation. So we do the first thing. So like in this case, usually we have already solved systems of two linear equations which has a unique solution. So now let's take a look at this. So we add minus 3 times of row 1 to row 2. Why? To eliminate again the x variable. So I won't go into this step of the left hand side and right hand side. We will get this. So the same thing. In the row 1, x is the leading variable. In row 2, there's no leading variable. So hence we can say that y is not a leading variable. So since y is not a leading variable, we can say that the system has many solutions. Are we clear? Oh, that's good since we are clear. So now let's go to this one. System of 3 unknowns but 4 equations. So the Gauss method still applies. So what do? You want to eliminate the x variable, so we swap first. So we swap row 1 with row 4 and a row 2 with row 3. So hence we get this. So we can eliminate the x variable first. So second step, what do? We want to eliminate x variable. So we add minus 1 times of row 1 to row 2 and minus 2 times of row 1 to row 3. Hence, for the first step, adding minus 1 times of row 1 to row 2, this is how it is. So this is the left hand side, minus x plus y plus z, and then plus x plus z will give me minus y, and the right hand side will be minus 10 plus 5 equals to minus 5. And for the minus 2 times of row 1 to row 3, minus 2x plus y plus z plus 2x plus minus y plus z will give me 4y minus z, and the right hand side will give me minus 20. So hence, this is how my next transform equation is. So for now, we want to eliminate the y variables on the third and fourth row. So we add minus 4 times of row 2 to row 3 and minus 4 times of row 2 to row 4. So you see, we add minus 4 times of row 2 to row 3. On the left hand side, we get minus z by doing this, and for the right hand side is 0. And for the minus 4 times of row 2 to row 4, for the left hand side, we get z, and on the right hand side, we get 0. So hence, this is how my transform system is. So now, we want to eliminate the z variable on the fourth row. So what do? We add row 3 to row 4. So this will be straightforward. Left hand side will go to 0, right hand side will go to 0. So this will be my transform equation. So you'll notice that the row 4 equation 0 equals to 0 is redundant. It's logical, but it's redundant. Hence, in this example, we can see that every row has a leading variable. X is the leading variable, y is a leading variable. On the second row, y is a leading variable. On the third row, z is a leading variable. So hence, we can still say that the system is in echelon form because every row has a leading variable. So x, y, z are all leading variables. So hence, the system, we can still solve the system even though there's this redundant equation, but logical equation. So we get z equals to 0 and y equals to minus 5, and we plug into row 1, we get x equals to 5. So let's take a look at the last example. Now we have 4 unknowns and 4 equations. So first step, we want to eliminate the x variable. So we swap, we bring all the row with the x variable to the upper one, up first, we shift up first. So we swap row 2 with row 3. So we get this, and then we swap again, row 3 with row 4. We get this. So this looks like a good equation for us to eliminate the x variables. So to eliminate the x variables, we add minus 3 over 2 times of row 1 to row 2 and add minus 2 times of row 1 to row 3. So these are the steps again. I won't go into detail. So this is how it is for the add minus 3 over 2 times and then add minus 2 times of row 1 to row 3. We get this. We get this equation. So now, this looks better, but we need to eliminate. We notice that row 3 and row 4 have two y variables, so we want to eliminate the y variables. We swap row 2 with row 4. Hence, we get like this, and this looks easier to eliminate. So we eliminate the y variables by adding minus 1 times of row 2 to row 3. So this is how it goes. As you can see, we might add minus 1 times of row 2 to row 3. This is how it works on the left hand side and right hand side. I won't go into detail again. So here it is. So now, you want to eliminate the z variables. This row 3 and row 4 have the z variables, so you want to eliminate one of them. So we swap row 3 with row 4. We get like this. So what do? We want to eliminate the variables. We add minus 8 times of row 3 to row 4. So the left hand side goes in this way. Minus 8. And then etc. etc. We get in this form. So you notice that every row has a leading variable and then systems in echelon form. So by solving it, we'll give For the bottom row, we will get w equals to 3, and then by plugging in into row 3, we get z equals to 0. And hence, it goes on, and y equals to 2, and x equals to 1. So that's all for today.